have this challenge, or like individuals have this challenge of enhancing their um, investments, right? And for that, they hand over money to their fund managers. Now, Ashok is going to be our fund manager and explain the challenges he faces while handling the money of his clients.
Thank you, Syed. Before talking about the problem that is at hand, maybe I would like to ask curious questions to our audience. Maybe how do you invest your savings? At the end of the month or at the end of the year, how do you do it? Anybody can be curious about it?
Yeah, sure.
Okay.
So like sometimes like some people are there, some of my friends also, they try to invest by themselves. Some may also approach the portfolio managers, fund
Yeah.
managers.
Yeah. So there are multiple ways, right? One is yourself. What you are going to do is you will assess multiple things like, okay, if I invest in the real estate, what is the my returns? If I invest in stocks, what is my returns? So you will look into, just returns, and you keep maybe completely in one of the assets or combination of assets. So similarly, usually people approaches fund managers who has more money and does not have time to invest and does not have knowledge to invest, right? So usually I receive a fund from different customers to invest in different funds. So usually what do they come up with? The any person while investing, they will look at returns. So they want to have some minimum target return. Okay, next 2 years I want to earn 25%. Maybe some other person maybe, no, I don't want that much, I am okay with the 15%, but I want to only invest in low risk funds, and the other person might be interested in invest in high risk funds, right? So there will be lot of customers that comes in. So now my challenge is, like, I need to find out what is the combination of funds that I select. So there might be different kinds of funds, like high risk funds such as IPOs, stocks, and medium risk funds such as gold features, low risk funds such as bank deposits and bonds. Means it is the risk is mainly about the stability of returns over the period of time, right? So now I need to make a decision now how I can do. So usually what I do, I will enumerate different up combinations, then finalize one of the option. But there is a work that can help to solve this problem, using mathematical modeling. Now, but my comfortability is about the tool. So I have been using my Excel for years. So now suddenly if you want to ask me, to move to some Python, I'm not much interested. So I I would like to see from your mind, how do they help me to solve this problem using Excel?
Selected asset. So as of now, we just randomly selected few of the asset in that from Indian market itself, from the large cap stocks, mid cap stock, some ETFs, and the real estate asset also we consider in this. So these are just randomly we selected some of those to show how we can create complete flow in the Excel itself. And we took the data from Yahoo Finance API, and this data is like this is like the historical prices of data, and we are just using for this webinar itself. So data whatever we collected is a weekly historical price data, and we collected it from March 2023 to March 2025. So last 2 years weekly asset price data we collected for the selected asset. So given this information, like this historical data we have, now we need to calculate for this making this model, we need to calculate the weekly data. So weekly return also you can directly write the simple Excel formula and calculate the weekly return corresponding to each selected asset. So weekly return for each week and for each asset is calculated in this sheet. Further, what we do is we need to estimate the expected return. So estimate of expected return is the mean of this weekly return itself. So that is calculated in this sheet, and it's just simply the mean of that particular column related to the real, that's it, it's real life industry. So this is just the mean of uh, historical weekly returns. So this table is telling us कि it's expected कि this Reliance industry will give us 0.21 weekly return, 0.21% weekly return. Yeah, after calculating this, because this is one parameter that is being used in the model. So this would be used in my in the optimization field where we would be defining the model. Then we need to calculate the covariance. So that is calculated in this sheet. So it's also like you just need to write one formula in Excel and it will calculate the covariance of historical weekly returns for each combination of assets. So that is calculated like Reliance and Reliance covariance between Reliance and Reliance is this value. Reliance and Tata TCS, this is the covariance. So this is how like you can calculate all the parameter also in the Excel. And now comes the main sheet where we are doing all the calculation and we are defining the model also, which further will be solved and optimal decision will be given to us. So yeah, as I said, like in these three rows, we are giving first the input that would be there for this model. So as I explained, the input would be from the customers. So what is the capital that customer has, which fund manager or portfolio manager need to invest? Second thing is what is the risk taking capability, which is portfolio volatility of the customer. So as of now, it's quantified by the portfolio manager, and let's say he's saying it's 10%, and the customer prefers he should get at least 28% return. So now what a portfolio manager have to do is he he or she has to decide these values, the proportion of investment in these assets, in these selected assets. So as of now, I just given the random guess, some random guess. कि I'm investing 30% in this ICICI Bank stock, the 15% in PEL, and so on. Like these are the percentage, and this is showing ki okay, 100% of allocation is done. If you see, you can see uh, in the money wise also, like how much rupees were invested in each of the particular asset. So this is the decision that portfolio manager has to take. But based on this decision, we will calculate the portfolio return and volatility of the portfolio. So that is calculated by the this simple Excel formula itself. So which is like we are taking the expected return and multiplying with the decision taken. P8 to P20 are the decision taken. This giving, okay, we according to this proportions, we are getting 27% return. And the volatility also, so the expression that I showed, W transpose sigma W, that is used to calculate the volatility and it's given here. So volatility was calculated, so which is coming out to be 10.33%. If you see, key this volatility limit is a bit higher, like 10.33, and customer has given only 10%. And the desired return was ROI was 28%, and we are getting only 27. So now what portfolio manager will do? Okay, he might try adjusting this. Okay, he want more return and even the risk also should be less. So maybe some other combination he might try. I'm not the portfolio manager, but let's see. Okay, I'm trying this. Some 14% in this and some 1% in this. So I'm investing complete money, but it's still like my risk taking according to this, I'm taking more risk and even getting 28, even not getting 28% return, which was desired by customer. So now portfolio manager has this question, is it possible in the 10% volatility limit, I can get 28% or more than that? So for that, we can use this mean variance model. We can define that model and solve it. So it like that model, the solver that would be using that will take care of all the combination, will give us the best result. So to do that, we use the analytical solver provided by the Frontline system. So I'll just brief you like how you can use this Frontline system analytical solver. So if you go to the website of Frontline system, there would be option to download the analytical solver. You can download it. You can opt for either the some license for some time, or you can go for the commercial license also. So once you download it, you install it in your system. In your Excel interface, you'll get this analytical solver tab. So once you go to this analytical solver tab, there are a lot of options. So like as of now, today, I will be showing you how we can use different options which are required in this model. So as I explained you, we needed to define mainly the three things. First is the decisions, my objective, and the constraints. So as of now, if you go to this model button, this side panel will be open where my all the model detail, solving it, everything is there in this. So if you go to the optimization section, you can see in objective something is there, return maximize. So this objective is uh, we have already defined. So because as you say, in this cell itself, we are calculating the return that would be that customer will get based on this decision, this proportion of investment decision. So this is the cell that I want to uh, maximize. So to add this in the model, what we have to do is, uh, so one more thing, because this cell I have given reference name as return. That's why this return is coming here. And to add this cell as the objective, what we have to do is we have to click on this cell. We'll go to the objective, this objective button, and we'll click on the drop down because this is a maximization kind of objective. We want to maximize the return. We'll go to the maximize and not because yeah. So now because it was already added, that's why it's like return to be maximized. Then we need to add the variables. So variables, we have already added this proportion of investment. Why this proportion of investment coming is? Because I have given a reference name to these set of cells, which are my decision as proportion of investment. So to add these cells, because it's not key, I have to add each one of the cells separately. It's like all the cells which are my decision can be added at once. So to add that, we have to select those cells. We'll go to the decisions, normal. So when I click on this decision normal, you can see like this proportion of investment is coming twice. That is because I have added this twice. So we can just remove one of the decision because it's repeating itself. Yeah. So now we have the third component, like how we can add the constraints in the model. So to add the constraint in the model, what we have to do is, let's say I'll explain because all those four constraints that I told are added in this constraint section. I'll explain like how we can add this portfolio volatility that then equals to customer volatility. If you see, this is the cell B26 is the cell that is calculating the volatility of the portfolio, selected portfolio. So, and I have given a specific reference name to this as portfolio volatility. I want this value to be less than equals to whatever limit provided by the customer. This value, this cell B3 value. And I have given a specific reference name to this as customer volatility. So to add this as a constraint, I'll first select the left hand side, which is my the calculated portfolio volatility. I'll go to the constraint button. I'll click on the drop down and normal constraint. And because it's a less than equals to type constraint, so I'll click on less than equals. So if you'll see, this add constraint pop-up is coming where left hand side is already selected. Now we'll go to this right hand side place and we'll just click on the right hand side cell, which is my B3 customer volatility. Once you click it, the reference of that is noted here, and it's like portfolio volatility should be less than equals to customer volatility. If I will just click on OK, that constraint would be added in. So because I have added it twice, I'll just delete the duplicate one. Yeah. Same way we can add this B21, which is like the constraint regarding 100% of investment. Return should be greater than equals to desired ROI and the portfolio of investment. So it is like bound constraint key. All these decision variables should be greater than equals to 0. Those cannot be negative. So after defining these three components, now my model is complete. So one facility that analytical solver provide is this analyze original model. If you click on the analyze original model, your model will be analyzed, which means like the type of model. If okay, it might be possible portfolio manager knows somewhat of linear programming or how mathematical modeling works. In that case, he can understand, okay, what kind of model is this? It is non-linear programming model. What are the variables, constraints, all those things are there. But if he doesn't know about this, they can skip this option or something. Like analytical solver take care of this by itself. Then comes because now we have just defined the model. Now comes the solver part, like how we will solve it. So to solve that also, they have some engines which are like kind of algorithms which will solve these problems. So problems might be of different kinds. So and for different kind of problem, different engine might be applicable, might be best to solve. So in this case, I'll just briefly tell you like these are the standard engines, the standard DRG non-linear engine, standard LP engine. These are some of the engines that are provided by analytical solver itself. And if you see like Groby solver engine, Mosaic solver engine, Express solver engine, these are some commercial engines that are used to solve very large problem. So which means if you have a very large problem, as of now we are just showing webinar and it's a smaller problem itself. If it is a very large problem, it's considering a lot of asset, thousand or lakhs of asset. In that case, uh, you can use some commercial engine also in the Excel interface itself. You just need to select that engine and it will work for you. But it has one more option. It's possible key portfolio manager doesn't know about this engine. I don't know which engine would be able to solve my problem. In that case, they can portfolio manager can tick this automatically select engine button, and the analytic solver will take care of selecting the best engine for this particular problem that is defined in this Excel sheet. So after selecting like this engine or automatically select engine, uh, portfolio manager come to this output tab, and this is the button to solve this problem. So it's just a one click and this problem will be solved, and it's saying ki solver has converged to current solution and all constraints are satisfied, which is like the constraints are satisfied and it's getting optimal solution. So now that is updated in this Excel itself. So this is the updated proportion. Initially, I just written some random proportion, and this is the updated one. Now, if you see, according to this proportion of investment, it's the risk volatility is portfolio volatility is 10%, and we are getting 30.66% of return, expected return. Which earlier, like by trial and error, we were just reached to I think 27 till 27 or 27.3. But optimally we can get this one by this combination. So if you see like with this 10% of risk, 10% of portfolio volatility, you are investing more in the safe stock. Let's say 30% itself is invested in gold ETF, which is considered to be kind of safe. And yeah, so I'll just explain you. So this is like the particular uh, proportion of investment that would be there according to this report. If customer, let's say another scenario, customer is willing to change this risk taking capability to 15%, and wants key, let's say I want at least 35%. So is it possible, or I can get some more return out of expected return out of it? So that kind of to answer that kind of question, because everything is defined now in the sheet, all the objective, constraint, and everything we have already defined. So what portfolio manager has to do is he will just change this input value. He will click on this button and it will do it for you. Okay, it has find a solution, which means it's getting 41% instead of 35. With this 15% risk, it's getting 41% of return. And yeah, calculated volatility limit is 15% itself. Now, if you see, it's investing more in DL stock because the way we have selected this asset, this was high risk stock, and because this technical capability we have in it, that's why optimal solution is looking over to this. But to find out the optimal combination, we need portfolio manager need this kind of tool uh, to solve. Yeah, so that is all for this webinar. Yeah, over
Sorry.
to you,
Ashok,
Sayed.
you
Yeah, it is. Thanks, Devendra. I think it is Excel has cool feature to help me. But okay, if I buy this solver from front end, what is the means? What is the my role here? How what is the value add that can be done by my for me?
Yeah, so that is a very good question. So let's say if you are coming to us and you are a portfolio manager, so first time it might be possible, first time understanding this mean variance model or different other models also very difficult, and maybe creating that complete flow or environment would be very difficult. So we can Orme can provide the customized services in that. Uh,
Okay, you will help me to build this model. Just
yeah,
I
Yeah,
can
so
play with
build this model,
just
like if you want some specific constraints also, let's say user may come up with something out of this, like whatever I explained, out of this also user may come. He wants, uh, like there should be preference key, okay, I want at least this much in particular asset. So in
okay.
that case, like we have to add customized constraints. Yeah, so these kind of things might be there where the customization might be needed. Expert might be needed who knows optimal this mathematical model kind of. So
Okay,
their portfolio
understood.
manager might do.
Thanks. Understood. Yeah.